Dear students, welcome to the chapter of concurrency control techniques in DBMS. In this chapter, we are going to discuss how two different transactions or two or more transactions work on the same data item concurrently, but still tries to produce a database which is in the consistent state. It is often possible that more than one transactions working on a database item may leave the state of the database in an inconsistent way or an inconsistent state. And we have discussed about how the transactions work in the previous chapter. Now, let us see the agenda of today's topic. Today, we are going to discuss how the concurrency control works and why is it required. We will also see a technique called as two-phase locking technique, which actually puts a data item in a locked state and then works on it so that the other transaction cannot interfere the working of the previous transaction which have locked the data item. We will see what are the different terms that are used in the two-phase locking, what are the different techniques, how the locks are upgraded or downgraded, or how the locking grows or shrinks over a data item. We are going to discuss about the limitations of the concurrency methods. We will see what is index locking. We will also discuss the compatibility matrix related to locking, and we will see what is the level of lock that can be done on a data item, which is given by its granularity that tells that a lock is applied over a field or over a record or over the table or the data block, the data disk block. So with that agenda in mind, let us proceed. The database concurrency control is all talking about the need, the purpose of concurrency control. We will see how to enforce the concurrency levels by using the laws of isolation or the different levels of isolation. Basically, to enforce the isolation, what do we mean by isolation here? It means that when a transaction T1 is operating on a data item X, it should feel that this data item X is only visible to this transaction T1 and no other transaction can work on this data item at the same time. However, we know that the data items, the database can be a multi-user database. Many transactions, many user can request the same data item. Now, there is a high possibility that different transactions or a concurrent transactions can go and make the changes into the data item X at the same time and may result the database to come in the inconsistent state. Hence, a mutual exclusion or a mutual understanding between the transactions are needed so that one data item is visible or looks like it is visible to a given transaction at a given point of time. This will help the transactions to not conflict with each other. Hence, we say that to enforce isolation through mutual exclusion among the conflicting transactions, this is one of the reasons why the concurrency control is needed. The second reason is to preserve the database to go in an inconsistent state. It means that we are trying to make the database consistent through consistency preserving execution of transaction. What do we mean by this? We make sure, using concurrency control, we make sure that transactions, even concurrent transactions, run in a way that they do not result the database to go in an inconsistent state. They make sure that the database is consistent throughout the running of the transaction, and even after completing the transactions, the database is left in the consistent state. The third reason why the concurrency control is needed is to resolve the read-write conflict and the write-write conflict. We have seen in the transactions or in the conflicting transactions that a transaction can have more than one action. It can have couple of reads and writes. But when two transactions work on a same data item and they are not reading, instead one is reading and another one is writing, then the way how the transactions are executed can result in conflicts. For example, if there is a data item X and I am reading on it and you are also writing on it, so there are a high possibility that I read the data item that you have changed, or I read the data item after you have changed, or I read the data item before you have changed. In either case, if the first read and the second read answers will be different. So this is an example of how two different transactions work on one data item, and if they are having actions like read and write, high possibility of conflicts arise. The details of this is given in the previous lecture already. So the conflicts can arise when we have read write, or write or read, or write operations from two different transactions. For example, here we are saying read hyphen write. It means the first transaction is reading, the other transaction is writing. It can be vice versa also. Here we say write, it means two of the transactions are writing. So they may, for example, T1 have changed the value of a data item X to 10, the other one wrote it 15. Maybe the other transaction has changed the value of X. So the conflicts can come. A conflict can come when you have a same data item and different transactions are trying to perform read write or write operations on it. In order to deal with all the problems that can come from these three reasons, the concurrency control is highly needed. Okay, now, because we are trying to resolve the problem that can occur by using a concurrent access of the transactions, we need to control this concurrency. That is why the chapter is named as concurrency control techniques. Now, example, we talk about this. If a concurrent execution, in a concurrent execution environment, if T1 is trying to read on data item A and T2 is also trying to write on data item A, they are trying to access it, then the concurrency control decides that if T1 should execute first and the T2 should stop, or T2 should get the data item A and T1 should roll back. So the concurrency control decides this based on certain rules. So so that the data item A is not left in an inconsistent state, because T1 and T2 are conflicting with each other to access this data item. I hope you understood. Now here we have one of the very popular technique, which is called as two-phase locking technique. In this two-phase locking technique, we have two operations. One is locking phase, another one is unlocking phase. Both of these two operations are atomic operations. What do we mean by atomic? It means that you can lock, either you can lock or you will unlock. So it is performed as one operation at a time. Now, here in this diagram, we see that when a transaction begins, the lock is kept on this transaction. The lock is attained for this transaction. For example, you have a data item X here and the transaction is beginning, so it will lock. The lock is acquired on this data item. And then after the transaction is finished, it means that the T1 have completed working with the data item X. So now T1 can release the lock so that this data item X can be made available to other transactions. Now obtaining a lock on this data item X means that other transactions cannot take other transactions, or T2 cannot access this data item X until this lock is released. This makes sure that T1 and T2 are not conflictingly acting on accessing data item X. Okay, locking is now let us see what is locking. Locking is an operation of securing a read lock or a write lock, also called as read permission or a write permission on a given data item for a transaction, for a given transaction. Here we set T1 and T1 as a transaction and X as a data item. So X can be locked or unlocked to read or to write. So this is the locking operation. Unlocking operation removes all these locks from the data item X when the transaction is done accessing it. Hence, it is said that unlocking is an operation that removes these permissions from the data item. Example is given here. It says that lock X is obtained on data item X on the behalf of a requesting transaction. Any transaction can request a lock on X for reading, for example. So a lock is obtained on X, and the lock and the data item X is given the access to the transaction T1 to work on it. Second example, unlocking X. Why do we unlock X? After T1 have performed or have finished performing on data item X, the lock has to be removed so that X becomes available to the other transactions. So unlocking X is an operation where data item X is made available to all other transactions. We are going to use these terms, lock of X, unlock of X, T begin and T end, often be coming up with some algorithms talking about the two-phase locking techniques. Hence, it is very important for you to get familiar with lock X, unlock X, T begin, T end over the timeline. Okay. So let's proceed further. Now, there is a lock manager which manages the lock on the data item. It may create a lock tables that looks something like this. The transaction ID, which is requesting for a lock on a data item, ID X1, for example. And what type of a lock mode does this transaction wants? It wants to lock X1 for reading. And then we have a pointer to the next data item. Here, for example, what will be the next data item after T1 finishes with X1? Maybe it can be X2, which is written here. Lock manager uses this table to store the identity of the transaction and the data item and the type of the lock that we want to have it on X1 and the pointer to the next item that is to be locked. One simple way of maintaining a lock table is through a linked list, because you see we have a next pointer here. So this table can be made in a form of a linked list too. So up till now we have talked about locking, unlocking, locking X and unlocking X, and also we have talked about locking manager. Yeah, we have talked about locking manager and locking table. Now let us understand what is a conflict matrix. A conflict matrix says that a data item can be locked or a data item can be locked in a shared manner when two transactions are trying to read. Okay, and a data item cannot be shared among more than one transaction when one transaction is trying to read, another transaction is trying to write. Similarly, first transaction wants to read, another transaction wants to write, we cannot share a lock. And similarly for writing, if two transactions are trying to write on a data item X, we cannot share the lock. This all creates conflict, right? Only there is a read operation from both the transactions that says the simultaneous reading is possible. Hence, the data item can be shared and we can have only a single lock, which is called as a shared lock, which will allow T1 also and T2 also to read in the same time. Hence, this conflict matrix produces the concept of lock modes. Now, what are the lock modes? There are two types of lock modes. One is called as the shared lock, the mode of the lock, for example. If the lock can be shared between transaction 1 and transaction 2 for reading purpose, then the lock, that is shared lock, will be used. The second one is using the exclusive lock mode for writing. When either of the transactions want to write, then we have to use an exclusive lock for that transaction. Now let us read more about the shared mode. In the shared mode, we use a shared lock where more than one transaction can apply for a shared lock on X for reading its value, only, but no write lock can be applied on X by any other transaction. It means that if you're trying to read data item X, if you're trying to read data item X and your friend also wants to read the data item X, you can have a shared lock so that other transactions doesn't change the value of X when you're reading, and then you both can keep on reading. It is same like, for example, you are trying to read the homework assignment given to you or in Google Classroom or in Blackboard. So you can read, your friend can also read from your screen, right? Unless and until, the assignment is not allowed to be changed when you are reading it. This is an example of a shared mode. The second one is exclusive mode, which is given only to one transaction. The shared lock can be given to more than one transaction. The exclusive lock or the write lock is given only to one transaction to work on X. Only one write lock on X can exist at any time, and no shared lock can be applied by any other transaction on X. It means that if X is locked to be written by T1, the T2 cannot apply for a reading lock or a write lock, or it cannot access until T1 releases the lock on X. We talk about the locking manager and the lock table. Now, next. Database requires that all transactions should be well-formed. What do we mean by well-formed? A well-formed locking system makes sure that the data item is locked before it is read or it is written. So before the transactions try to read or to write the value, new value into data item X, for example, it must apply a lock. Okay, so this is a well-formed one. Another one is it must not lock any already locked data item. What do we mean by this? If X is already locked by T1 for writing or for reading, then T2 cannot lock this, cannot overlock on this data item X. It must not lock an already locked data item, and it must not try to unlock a free data item. Now, what do we mean by this? It means that it must not try to unlock. Yeah, it means that if the data item is not locked, we cannot unlock it. As simple as that. So this makes a well-formed state of a lock. And DBMS requires that all the transactions to be well-formed.